One of the angles that we use a lot in trig is 45 degrees. So we want to get familiar with this angle and its multiples in degrees and radians. So if we start off with the 45 degrees and we convert this to radians, we're going to multiply 45 degrees by the ratio pi over 180. So 180 degrees, the degrees will cancel. We can do a little bit more canceling by saying that 45 goes into 45 one time and 45 goes into 180 four times. So what we have in the numerator, we've got 1 times pi. In the denominator, we have 1 times 4. So we want to remember that 45 degrees is pi over 4 in radian measure. Okay, we're going to use that to find these other angle measures in radians. So 135 degrees is equal to 3 times 45 degrees. So replacing that 45 degrees with what we have in radian measure, pi over 4, we get that 135 degrees is equivalent to 3 pi over 4. Now let's look at 225. Well, 225 is equal to 5 times 45 degrees. So 5 times, replace 45 with pi over 4, we get that 5 pi over 4 is equivalent to 225 degrees. And then finally, let's look at 315. 315 is equal to 7 times 45 degrees. So we can write that as 7 times pi over 4, or we get 7 pi over 4 is equal to, in degree measure, 315 degrees. Now let's look at the special angle of 45 degrees, or pi over 4, on the xy axes. So if we look at 45 degrees, pi over 4, we are going to just cut the first quadrant in half. So this angle from the initial side to that terminal side has a measure of 45 degrees, or pi over 4. And if we looked at just this angle here, this also would have that same measure, right? And then added together, we get 90 degrees, or pi over 2. All right, so every quadrant is made up of 2 angles of measure 45 degrees. Let's write this 90 degrees, or pi over 2, in terms of pi over 4s. Well, if we count it out, we have, here's 1 pi over 4 plus another pi over 4. So that's 2 pi over 4s. So 2 times pi over 4. And then we see that we write that as pi over 2 because the 2 and the 4 is going to cancel. Okay, let's look at 3 pi over 4. So that's going to cut the second quadrant in half. And if we count out those pi's over 4, we have 1, 2, 3. So that is 3 pi over 4, equivalent to 135 degrees. So counting out another pi over 4, 1, 2, 3, that gets us to a quadrantial angle of 180 degrees, or pi. In terms of pi over 4s, we can see that it is 4 pi over 4s. So 4 times pi over 4, and of course those 4's cancel, and that gets us to that pi. So we count out another pi over 4. We go 1, 2, 3, 4, and that gets us to 5 pi over 4, the angle that cuts the third quadrant in half. 5 pi over 4 equal to 225 degrees. Now let's count out another pi over 4. That's going to get us to 1, 2, 3, 4, 5, 6 pi over 4. Well, that's the quadrantial angle, 270 degrees, or 3 pi over 2. In terms of pi over 4s, it's 6 pi over 4s. And we see that the 6 and the 4 cancel, and we get back to that 3 pi over 2. All right, counting out one more pi over 2, we get to the angle that cuts the fourth quadrant in half, and that's 7 pi over 4, which is 315 degrees. So let's look at this example. It is like number 5 on the assignment. First thing we want to do is draw the angle negative 135 in standard position. So standard position, we're starting at the positive x-axis for the initial side, and because it's negative, we're going to go in a clockwise direction. So remember that negative 135 degrees is like negative 3 pi over 4. So that means we can count out pi over 4s. So we are going to count out 1 pi over 4 would be here, negative 2 pi over 4 would be here, so that gets us to negative 3 pi over 4, cutting the third quadrant in half. So we went in this clockwise direction, negative 135 degrees. So that takes care of number 1. So number 2, we want to find a point on the side, that terminal side. Okay, well, here's a point right here, negative 2, 2. And it asks us to find the distance from the vertex to that point. So we're looking for this distance that I have here in green. Okay, let's put this side over here, and we see that we've got a right triangle with the distance that we're looking for being the hypotenuse. So here we want to use the Pythagorean theorem. So let's say this side is A, this side is B. All right, so Pythagorean theorem and the distance formula, we are going to take the distance is the distance B squared plus the distance A squared. All right, those are the lengths of the two sides of that right triangle. So the distance is going to be the square root of B. All right, well, B has a length of 2, so we get 2 squared, and A also has length of 2, so we get 2 squared. So we're going to get distance of square root of 4 plus 4, or the square root of 8, which simplifies to 2 square root of 2. Okay, for part 3, we want a positive and negative coterminal angle for our angle negative 135. So our positive angle is going to be going in the counterclockwise direction, so we want this angle that is in black. So if we remember how we find the positive coterminal angle is we take our original angle, negative 135 degrees, and we're going to add 360. So we end up with 225. So this angle in black has an angle measure of 225, which we know that's the case. That's if we counted it out, that would be 5 pi over 4s, which is equivalent to 225. Now we want the negative case. So that is the angle that goes from that same initial side, one more whole revolution back to that same terminal side. So to find that angle measure, we start off with our negative 135. Because we're going in the negative direction, we subtract 360 degrees, and that gives us angle measure of negative 495 degrees. For the last thing, let's convert these results to radians. So 225, that's actually one that we know. That's 3 pi over 4. So for negative 495, let's use our conversion. So we multiply that by pi over 180 degrees. All right, degrees, we know those cancel, and we also can cancel before we multiply. 45 goes into 180 4 times, and 45 goes into 495 11 times. So to get our result here, we multiply negative 11 times pi, and then we've got 1 times 4 in the denominator.